the good news is for me is that, you know, I edit the videos, so my boss never gets to see me inflicting these bad jokes on you, because I normally cut it off before this happens, but not always. Okay, so we are looking at how do you find limits using the limits laws? Essentially, how do you find limits, exact values, using algebra? And here are the 4 techniques: evaluate, factor and cancel, conjugate, and then the 4th one is basically just a catch-all. You do it, you finally got the joke, Sabrina, you're laughing now, okay. So the last one is algebra. Basically, you simplify it in some way or other. The 4th one is the hardest one because it really doesn't fall into one category. It's basically everything else that's left belongs there, right? If you can't find how to solve it using these 3, then it's one of them. So let's look at the first kind, evaluate. Now, what the law of limits says is that if you can plug in the number, just what I'm about to do right now, if you can plug in a number to the expression and you get an answer, then that's the limit. So it's basically, if you can do 2 lots of 7 add 1, and you can do 7 add 3, you will get 15 over 10. And we like that answer. So don't call it 1.5 and don't call it 1.5. In mathematics, 3/2 is considered the better form. Right, so that's the one I would prefer you to use. Evaluate questions are very easy. Don't you just plug the number in? If you get an answer, that's the limit, right? No frills, don't overthink it. It works. However, most of the time, aren't you going to try that and you get the dreaded 0 over 0, right? That's what's probably going to happen in the vast majority of situations where you try to evaluate it. Let's put you on the spot a little bit. Can anybody remember what name we give to this situation? What's it called when this is happening?
The indeterminate.
That's the one. So it's called the indeterminate form. Right? So when that happens, don't we have to use one of the other techniques? But that would be my go-to first. You know, I would try and do it, you know, even if it's just do it in my head. Yeah, that's going to be 7 over 42. That's going to be fine. Do it. If you do it in your head and say, oh, the top's 0, the bottom's going to be 0, well, you know you're not even going to write it down, right? You just do it in your head. There is another version of the evaluate method, and it looks something like this. Suppose I tell you that the limit as x tends to 3 of f of x is 10, and that the limit as x tends to 3 of a different function is -2, and the limit as x tends to 3 of our last function, we'll call it h of x, is 5, right? Then you can actually find the limit, as long as it's x tends to 3, of any expression that uses f, g, and h. For instance, f of x times g of x divided by h of x. What the evaluate method says, the law of limits says, is that you can separate out this calculation into what that guy is equal to, multiplied what this limit is equal to, and divide it by what that guy is equal to. And so what does that mean? In this case, 10 times -2 divided by 5. So 10 times -2 divided by 5, and I believe the answer is -4. And question 1 in the homework looks like that guy. Now, you can do all sorts of calculations. For instance, I can find the limit as x tends to 3 of g of x cubed. What else? Times the square root of f of x divided by the square root of h of x. I'm just being crazy here. I'm just doing weird calculations. Now, according to the law of limits, since I know the answer to g of x's limit, f of x's limit, and h's limit, can't I just say that guy, which is what, -2, cubed, square root of that guy, divided by the square root of that guy? Great. And that guy is what, -8? Oh, here's a little thing. Can you simplify the square root of 10 divided by the square root of 5? What can that simplify down to?
The square root of 2?
Yeah. And so there's your answer. Are we okay with evaluate, or do you want to say another one?
Can I do one more?
Sure. Let's pick, do you want one with F's and G's in it, or do you just want one that's got like expressions? What kind would you like to see?
The expressions.
Don't care? Don't care?
Yeah, don't really.
Okay. Let me, okay. This is question 3, or at least like it. WebAssign keeps changing the numbers, so any question I do probably won't be the one you'll see. Okay, you can plug in 4. It's 8 take away a half of 4. 8 take away 2, the answer is 6. So in the evaluate method, you really just plug in 7 or 3, well, or 4, or technically 3, and you find out what it's built from, and you've got your answers. In these questions, you know it's x's, so you just replace the x by 4, or in this case up here, you replace the x by 7, and then you get a calculation, which you'll be able to get. And that should be your first approach. I'll just try and evaluate it. And most of the time, it won't work. But for the few times it does work, it's worth it. And what happens next then is that you try to evaluate it, but you get 0 over 0. In which case, one of the techniques that you're likely to use is the factor and cancel method. So let's do, let's find one. Okay, this is question 4. The limit is x tends to 7 of x squared take away 2x take away 35 over x take away 7. Now, I would probably try and evaluate this first, but can you trust me that you get 0 over 0? Right, so we know it doesn't work. So we're now going to do factor and cancel. So if I see an expression, a fraction, they're pretty much always fractions, right? If I see a fraction and there isn't any square roots anywhere, then I'm going to do the factor and cancel method. If I see a square root, I'm going to do the conjugate method. So if you're trying to think, how do I know to do the factor method? How do I know the conjugate method? If there's square roots, it's conjugate. If there's no square roots, it's a factor and cancel. Now that brings out a technique that you have used a lot in your math life. you have to factor everything, top and bottom. In this case, only the top, because the bottom's fine. And I am looking for two numbers that multiply together that give me -35. And when I combine those two numbers, you get -2. Right? What combination works?
Positive.
I have -7 and +5. Agreed? Now, here's a little trick to these questions. Do you notice how this term had x minus 7 in it? Right at the bottom. I can guarantee that one of the two factors is also going to be x minus 7. Now, why could that be helpful? Can you imagine that this quadratic was really ugly? Can you imagine that this quadratic was a number like, I don't know, 60? Isn't there an awful lot of factors to go through in your head to find the one that works? Well, if you already know one of them is this, shouldn't you be able to figure out who the other one is? So you already kind of know half the answer before you even factor it, right? If the bottom's got an x minus 2 in it, I know the top's going to be x minus 2 times whatever else, right? And that kind of reduces your workload, and it's a nice little trick to use. So you factor it, and then you cancel. This guy cancels this guy. So what we have left here is the limit as x tends to 7. Technically speaking, this is x plus 5 over 1, but I think most people would just call it x plus 5. Would you agree? There's no reason to put the over 1. Right, it's redundant. So the original horrible fraction that we couldn't find a limit to has now been reduced algebraically to this fella. And the laws of limit says that you're allowed to cancel factors. And now I can plug in 7 for x and get the answer 12. Now, isn't that much cleaner than trying to take this fraction and doing a big table of values, you know, and doing the 6.9999 guy and the 7.0001 guy and getting really annoyed with 12 decimal place answers that you have to write all over the place? And even when you do that, don't you not get 12? Don't you get 11.9998 and 12.003, and then you make an intelligent estimate that the answer is probably 12? Agreed? Now, if I put that into a calculator or Desmos and I looked at what the function looked like at 7, I think I'd probably figure out 12 reasonably easily. But can you imagine that the answer might be 4/17 the next time? Now, if you go to Desmos and you look at it, isn't 4/17, it's impossible to tell what that is, because Desmos doesn't tell you 4/17. Won't it tell you 0.3579998 or something? And that's, you know, I don't know what that is. And if this answer here was something like 4/7, wouldn't you also, if you did a table of values, have the same problem? Because the table of values would be decimals, and you wouldn't be able to tell, looking at many decimals, what that fraction is. I'm going to do a little test. Suppose you did a table of values or you did Desmos, and that's what you believe the limit of a function is. What fraction is that? I don't have a clue. Well, I do, because I picked it. Would you agree that you'd probably get old trying to guess that it was that fraction? Won't this method get you that fraction? Have I sold you on the algebra methods that we're using? Are 1, nicer mathematically, and 2, give you an answer that is exact every time, and you don't need to worry about what funny decimal is, because you're not going to get any funny decimals, right? You're going to get fractions. Let's do another factor and cancel. Let's try this fella. This is a version of question 5. The limit as x tends to -5 of x squared plus 5x over x squared. Oh God, I'm getting deja vu here, but too late now. Minus 2x, take away 35. Okay. No pressure. You got 1 minute. Do that one. I'll do it with you later. Find that limit, factor and cancelling. Time up. Okay, Sabrina, I'm going to put you in the spot. You ready?
Ready.
Go for it.
5/12.
I'm doing the top one. No, I'm taking the top one. I'm taking the easy one. Right, you got the bottom one. Yeah. Okay, you got the bottom one. Factor this guy.
All right, we've got x plus 5 and x minus 7.
Do you know if you use the fact that you know x plus 5 has to be one of the answers, doesn't it make it easier to figure out the second one?
Yeah.
Although there's not a lot of combinations for 35. Okay, so I'll take over. You are perfectly correct. Would you agree they cancel, as you'd expect in this method? Factor and cancel. And now we're left with that guy. -5, -5, take away 7, -5 over -12, positive 5/12. Does factor and cancel seem like an intuitively sensible process? It's not that weird, right? You factor the top, you factor the bottom, you get some cancelling, and the ugly question typically turns into a nice question that you can get the answer to. Are we good with factor and cancel, or do you want to see another one?
Good.
We're good. Okay. Anybody last chance? Okay. Let's look in our next method. Right. Whenever you see a limit and there is a square root somewhere or other, you know that you are looking at the conjugate method, right? So let's show you an example of that. This is question 11, or at least like it. It's a limit as h tends to 0 of the square root of 64 plus h, take away 8 over h. That's what I mean by there's a square root involved. So do you see this guy here, the square root? That means conjugate method. Now how does that work? Well, what you do is that you alter the look of this fraction by multiplying it by a special version of 1. And the special version of 1 is this guy here, the one with the square root, but instead of a take away 8, you do an add 8. So it's the square root of 64 plus h, add 8. And since the top and the bottom are the same, isn't that a special version of 1? And this thing here, the square root of 64 plus h plus 8, is called the conjugate. And that's why that's called the conjugate method. So what we're going to do now is the bottom two, I'm not going to do anything. I'm not going to distribute it. I'm just going to write them down like that. On the other hand, I'm going to FOIL the top two. So let's see what that looks like. The square root of 64 plus h times another square root of 64 plus h gets you 64 plus h. That square root times plus 8 gets you 8 square roots. That negative 8 times the square root gets you negative 8 square roots. And lastly, that negative 8 times that positive 8 gets you negative 64. Are we comfortable with the FOIL, right? The FOIL. And this is not a coincidence. This actually is going to happen every single time you do the conjugate method. Do you notice that the two terms in the middle cancel each other out? That's always going to happen. And if it doesn't, check your FOIL, because it will happen, right? Which means that I don't have any more square roots to worry about on the top. Right? And now all I'm going to do is collect like terms. And the original has now turned into this guy. But there's some things that we can do now that we couldn't do with the original. And can you see what I'm about to do next? Great. Can I cancel the h's? And so my fraction becomes even simpler. And at this point, can't I just plug h equals 0 in, right? And I should have my answer. And it's 1 over square root of 64 plus nothing, add 8. That's 8. 8 add 8 is 16. And there's your answer. I just love that. I don't know, there's something about that is so elegant in my brain. I think it's just because I wonder how the guy who figured this out. I just wonder what was going on in his brain where he thought, hey, this is a good idea. I think I'll try it. You know, it's, you know, if you read anything about the history of math, sometimes these things, I'm making this up, but he's drinking a beer with his pal. He's in, you know, some bar in Belgium, and they're outside on a summer's day, and he's drinking away, and then suddenly it hits him, and he grabs a napkin and a pen, and he frantically writes it down, and it works, and boom, it's done. Sometimes thoughts just appear, right? Have you ever done something and then suddenly the idea of, oh, maybe I should do that? Like you've got a problem with your car, and you just can't figure out what's causing it. And then, you know, 2 days later, you suddenly think, why don't I check the fuses? You know, it's like a light bulb goes on. You know, that kind of thing. That's maybe what happened to you. You know, just somewhere out of the blue, he was working on this problem and suddenly his brain said, hey, What about trying this? Okay, let's try this. Let's make your life a little bit more awkward, just a little bit. Still the conjugate, but we're going to test your knowledge of cancelling and factoring. Right. If you plug in 2 there, you get 0 over 0. Right. Okay. Let's look at the conjugate thing. Now, there's no reason in the world that the conjugate is always on the top. Would you agree in this case the square root's on the bottom? Right? The conjugate is the same 2 guys, but with a plus. I would go with that. Are you happy about why this is used in this question? Right? The square root guy minus 2, square root guy plus 2. That's what the conjugate does. In this case, I'm not going to do anything at all to the top, but these 2 guys I will FOIL out. And now I'm going to do a shortcut. If you don't like this shortcut, just FOIL it. But did you notice that the last time we did it, the middle 2 terms always cancel each other out? And the reason they do that is that, do you recognize this as a difference of 2 squares? And when it's a difference of 2 squares, you know, like a squared minus b squared, don't you just get that guy squared, take away that guy squared? So if you want to save a line of working, this times this is actually that guy squared, take away that guy squared. Now, if you don't like that shortcut, can you just FOIL it out the usual way and then the next line you'd get there? I'm just trying to reduce workload. And here is what I was getting at the start of this question. Hey, you promised us that you could cancel. You said you would always cancel. I don't trust you anymore. You've been lying to us. I can't see any cancelling going in here. What's going on? Look again, you can cancel. You can, can't you? What happens if you cancel a 2 minus x with an x minus 2? Because they are allowed to cancel, but what gets left behind? Come on.
A -1.
What gets left behind? A -1. Right. Three minus x over an x minus 3. If they cancel, you get a -1 left behind.
In other words, you just
You
factor
better
in a
tell me.
-1.
Yeah, and cancel it the usual way if you want to. So what that means to me is that the answer is negative. So it's going to be negative, right, that guy. Now that I've shown you that, can you vaguely remember it happening at least somewhere in your algebra life, right? That an x minus 1 cancelled out with a 1 minus x. Hopefully, whoever you got should have done that at least once or twice just to show you it happened, right? And if they didn't, shame on them. But I've told you now, so you'll remember it, right? That's what you do. And now I can plug in the number. Square root of 2 add 2 is the square root of 4. 2 add 2 is 4. The answer is -4. So we have found the limit to that ugly fraction. I wasn't happy about the 2 minus x, x minus 2 thing, because it looked to me like either you'd never seen it or you'd totally forgotten that you knew it. You know, that's a little thing. I know it's just a tiny little thing, but can that screw up your question? Because you're just going to look at it and say, I'm stuck. You know, little things can do that to you.
I've never seen it before,
Okay,
but
so
it makes sense. So I should remember it pretty easily in the future.
Yeah. Wow. So if you've never seen it, won't you just say, okay, file a fax? You know what's going to happen. You're never going to use it now for another 6 months. Right? It's just not going to happen anymore. It's not a thing that happens like every single question, right? So it's like, oh yeah, I've done that 100 times. I know that. You see it once and then you don't. So I'm moving up the food chain here with the conjugate method. Conjugate method happens when square roots are involved, right? Would you agree this thing has some square roots? But this time, 2 square roots. Normally it's a square root of 3 plus t minus 4, right? It looks like that, right? I'll take a volunteer. What's the conjugate going to be? What's these two guys?
Square root 3 plus t plus square root 3 plus t.
First guy plus second guy? Agreed? Top and bottom,
Yeah.
of course. Yeah. Does that kind of intuitively, does that sound reasonable to you, that that's what the conjugate would be, right? So it could be square root of something minus 2, 2 minus the square root of something, square root of something minus the square root of something, right? There's all sorts of permutations of what the square root could be like. But the conjugate is first guy add second guy. It's not very mathematical, but that's what you do, isn't it? First guy add second guy. Now, in this case, I won't do anything to the bottom. If you take this guy and you multiply it by that guy, and if you do it by FOIL, that's totally fine. If you do the shortcut, isn't it the first guy squared, take away the second guy squared? Remember, that's the shortcut. First guy squared, subtract second guy squared. If you take this guy and you square it, you get 3 add t. Take away, if you take the second guy and square it, you get 3 minus t. Are you happy about where this would come from? And if you're not, just FOIL it out and write it down. So what do you get? 3 take away 3, t take away a negative is 2t. Okay. Cancelling is pretty obvious, I think, this time. Can't you cancel a t? And we are now looking at the limit as t tends to 0 of 2 over that square root add that square root. Well, if you plug in 0 here, you'll get 2 over the square root of 3 plus the square root of 3. I mean, it's correct in a sense, it's the right numerical value, but I definitely don't like the way it's written. And I hope you don't like the way that answer is written. Shouldn't we always try and write the answer in its nicest form, what I call style points, right? So right now it's not getting a lot of style points. Any suggestions for making it look prettier?
Change it from adding 2 of the same term to multiplying the term by 2.
Okay. Basically that, if I pick up right. Would you agree? In this particular case, can we do anything else?
Can cancel the 2s.
Okay. Now, this is where WebAssign gets really annoying. In some questions, you will plug that into WebAssign and it will say great, big green tick, and you're happy. And then the next question, you'll plug that in and it will say a big red X, you're wrong. If you rationalize the denominator, which basically means you multiply by that special version of 1, you've got that. Mathematically, this is considered the ultimate form of what the right answer should look like. There's a rule in math that says, if you've got fractions, you really shouldn't have square roots in the bottom, if you can avoid them. Sometimes you can't help it, but if you can avoid them, you should. So that will always be understood in WebAssign. So if you type that in, WebAssign is going to say, great. Sometimes it will take this less than perfect version, and other times it won't. Well, why is that going to be important? Can you imagine that you did the answer correctly, but you typed this in, and WebAssign then said you're wrong? Isn't your first conclusion going to be, I don't know how to do this. I thought I knew how to do it, but I got it wrong. I've screwed up. And you're trying to figure out where your algebra went wrong, and you do the whole question again wrong, you know, and whatever. And you go a whole load of work that's not necessary. If this is your answer and you get a cross, will you remember that sometimes you need to turn it into this? In fact, it's probably a better idea to just always turn it into this one here. And then you won't need to worry about WebAssign being awkward and sometimes giving you the point and sometimes telling you that you're wrong. And I think that just saves a whole load of grief. Okay, to finish today, I am going to give you one last one to try out yourself. There you go. Because it's such an ugly question, I'm going to give you 3 minutes. Good luck. Off you go. Just going to write it down again over here. Oh, by the way, that's, oops, excuse me. That is the worst conjugate question I could think of. So you're probably going to find most questions, in fact, almost every question is going to be a lot easier than that one. But if you can do this one, you can do any conjugate one. for those who need a little help, last few seconds coming up. Okay, let's get started. This is the original. The conjugate is going to be these two guys added. The bottom two terms, I'm just going to leave them alone. If you take this guy here and you multiply it by this guy here, if we do the shortcut, won't it be the first guy squared, which is x squared plus 1, take away the second guy squared, which is 4x add 6. And that becomes x squared minus 4x minus 5. Agreed? Hopefully you got that far.
Yeah, use the wrong sign.
Yeah, you're almost there. Takes more time to write this than it does to do the question. In this question here, it looks like we have a problem. You promised me it would factor and cancel. I don't trust you anymore. Well, give me a chance. Can you factor this? And isn't its factor actually x minus 5, x plus 1? And didn't the conjugate come through for us? Because I can cancel that one. So what we're left with now is the limit as x tends to 5 of x plus 1 over that guy plus that guy. But I can now plug in 5. 5 plus 1 gets me 6. 5 squared plus 1 gets me the square root of 26. In here it gets me the square root of 26. So that gets me 6 over 2 lots of the square root of 26. Okay. I'd be quite happy actually if you'd got that far, even although it's not going to be my final answer. Would you agree that this fraction can be simplified, right? We can do style points on it. Right now, it's probably only going to get like 2 points out of 10 because it's still pretty ugly. How about cancelling a 2? Now that's a little bit prettier, would you agree? Rationalize the denominator. And you get 3 square root of 26 over 26. Agreed? 3 and 26 don't share any common factors, so I'm finished. I hope you got that one. There's a lot of places where it could have gone wrong. You would never, ever be able to get that answer from a table of values. Would you agree? table of values is just decimals, right? You'd never be able to figure out that. And I I know you cannot read that off a graph. Would you agree? You couldn't go to a graph and say, oh yeah, that y coordinate is 3 root 26 over 26. Because all you will get is it's 5.1234567, right? You get some weird decimal, but you won't know it's that. Okay, say hi everybody and bye-bye. I'll